Hi, good morning or good afternoon, wherever you are. We're excited to be here to discuss resiliency and sustainability. Our agenda will include brief introductions about ourselves and our companies. We'll talk about why speaking about sustainability and resilience and discussing these topics is important. We'll define sustainability and resiliency, synergies, and conflicts between them. We'll discuss case studies that exemplify incorporating sustainability and resiliency in them. And then we'll move on to takeaways and conclusions. My name is Monika Serrano. I am a mechanical engineer by trade. I've worked in the construction management industry for 17 years in different capacities. Half of that time has been spent in the field. Half of that time has been spent in pre-construction, cost, and engineering project teams. I developed an interest and later a passion for climate change in the last few years and quickly realized that I wanted to spend the rest of my career making sure the built environment was not contributing to climate change. I am aware I probably will spend many years, if not decades, making this happen, but I'm happy to report that for the last 2 years, I've had a full-time job trying to make our buildings resilient to climate change and other disruptions. I work for Turner's headquarters sustainability team, and I lead our resiliency program, which includes the resiliency of the buildings we built, our operations, and our workforce. Turner Construction has been around for 100 years. We have 45 offices in the US, more than 6,000 employees in the country, and up to 10,000 employees globally. We're mostly construction managers, but about 10% of our projects are design built. We build anything but roads and bridges. We build large buildings, but also perform plenty of interior renovations. We build and renovate hospitals, data centers, schools, stadiums, airports, community centers. Our clients are both private and public. The size of our average project is $11.4 million. And we complete an average of 1,500 projects a year. 80% of our clients are repeat clients. For the last 13 years, we have been the top green building contractor per the ENR, which stands for Engineering News Record, and we're very proud of this fact. But a few years ago, we realized that if we take away all of those green buildings, we didn't have much left in terms of sustainability. So we accelerated our efforts. Our headquarters sustainability department grew. We launched our Turner 2030 goal, which consists of decreasing our greenhouse gases emitted during the construction phase by 50% by 2030. We played a big focus on resiliency, even putting a full-time person dedicated to the topic, as well as dedicated attention and resources to other topics like embodied carbon, waste, net zero, and renewables. This is not just coming from us, it's also being driven by clients who are increasingly asking about these topics and putting value on sustainability and resiliency.
I am Ricardo Medina from Simpson, Gompertz and Heger. I'll tell you a little bit more about SGH in a few minutes, but I am a structural engineer by training. I work at the Engineering, Mechanics and Infrastructure division of our company. And outside of SGH, within the infrastructure resilience space, I'm a member of the Executive Committee of the American Society of Civil Engineers Infrastructure Resilience Division, as well as a founding member of the ASCE Structural Engineering Institute Resiliency Committee. Let me tell you a little bit more about Simpson, Gompertz and Heger. We're a national engineering firm that designs, investigates, and rehabilitates structures, building enclosures, and materials. Our team members include engineers, architects, scientists, and many other technical professionals. We have projects in the United States, Canada, and more than 30 additional countries, and a little bit over 600 employees distributed among 8 locations across the US from the East Coast to the West Coast, as you can see at the bottom of the screen. In terms of our markets, we serve the buildings market, the energy sector, civil and infrastructure, as well as science and defense, and we're committed to incorporating sustainable and resilient practices into our projects.
Now let's talk about why it's important to discuss sustainability and resiliency. It is estimated that over the next 35 years, 2.5 trillion square feet will be either renovated or built. This translates to saying we're going to build another New York City every 35 days. Another New York City every 35 days. That's a staggering number, which is great news for the construction industry. This means that we're all going to be very busy. For future individuals, this may have additional meanings. The impact that buildings have on our day-to-day lives is convoluted. We spend 90% of our time indoors. So in theory, buildings should affect our lives positively. But we have not historically designed and built buildings with this in mind. And in our defense, there was a lot of information that we didn't know. There's information like toxicity of materials, the need for us to move during the day, the need for us to have good air quality, and the need for buildings to keep us safe. There's another challenge. In order to build and operate buildings, greenhouse gases are emitted. So let's dig into that relationship between greenhouse gases and buildings. Greenhouse gases, usually referred to as the unit that most commonly used to measure them, equivalent of CO2, and that's why you can see CO2 in the graphic on the slide. They're emitted when we extract materials from nature, when we manufacture materials, when we transport them, and then install them in buildings. All of that is referred to as embodied carbon. And then when we operate buildings, when we repair them and rebuild them, more greenhouse gases are emitted. As an industry, the building industry emits or is responsible for at least 49% of greenhouse gases emitted globally. This breaks down into about 28% that comes from building operations and about 21% from building materials. Keep in mind that as buildings become more efficient, and they are becoming more efficient, that piece of the pie in teal will become smaller, and greenhouse gases coming from building materials will become bigger. The bottom line is that we construction folks are responsible for a lot of the greenhouse gases emissions. And why should we care about greenhouse gases emitted? Historically, the levels of greenhouse gases in the atmosphere for the last hundreds of thousands of years, take a look at the x-axis. Those are hundreds of thousands of years. So 800 is 800,000 years ago. Greenhouse gases levels in the atmospheres have stayed between 170 parts per million to about 300. And let me clarify that greenhouse gases are not all bad. The existence of greenhouse gases in our atmosphere is what allows us to exist as a species. But in the last 80 years or so, the levels of greenhouse gases have increased to unprecedented levels. And there is a relationship between increase in greenhouse gases levels in the atmosphere and increase in global temperatures. And then there's a direct relationship between increase in global temperature and extreme weather events intensifying and being more repetitive. In the graph in the slide, you can see that so far the average global temperature has increased about 1 degree Celsius, which is about 1.8 degrees Fahrenheit. It doesn't sound like a lot, but it in fact brings along some pretty harsh consequences to the way our planet works. This is a projection to what would happen if emissions continue rising. And you can see that in the line in orange. If emissions growth peaks in 2080, and that's the line in yellow, you can see that the temperature will rise about 4 degrees Celsius. If emissions growth peaks in 2040 or 2050, then the temperature will go up just under 3 Celsius. And if we reach zero carbon, which is ambitious, by 2050, ambitious but possible, temperatures will rise just about a degree Celsius. And again, this is important because greenhouse gases concentrations increase, temperature increase, and if the temperatures increase in the atmosphere, extreme weather events intensify and the frequency also increases. We're already seeing it now. The wildfire season is longer. Wildfires are threatening the west coast of the US and many countries around the world. Our air quality is being affected. In the last few months, floods have affected the northeast of the US, Germany, the South, Hurricane Ida hit New Orleans. Last year, we ran out of alphabetic letters to name hurricanes. And extreme heat is a threat. Heat waves have hit the northwest of the US and Canada, and droughts are threatening California and the Midwest. Along with these disruptions come consequences like utility interruptions and water shortages, which affect agriculture and our food production. The IPCC report, issued in August this year, stated for the first time that some changes from climate change are irreversible. And what are we to do as members of the construction industry? What does this mean to us? What can we do? We suggest we transform the way we do business and use this global challenge as an opportunity. We are building at a staggering speed, so let's make some real positive change at that speed as well. Some folks are already doing it, and many of us have the knowledge and the ability to do it. We could transform the way we build and operate buildings by incorporating mitigation and adaptation into the way we design, build, and operate buildings. Adaptation includes, for the purpose of this presentation, also preparedness and planning. Let's define mitigation and adaptation. Mitigation refers to reducing the levels of greenhouse gases in the atmosphere. And there's a direct relationship there with sustainability that Ricardo will explain shortly. Adaptation refers to embracing change, understanding that some of the changes from climate change are irreversible, and planning for that. And that is directly related to resilience.
Yeah, the conclusion is that sustainability can be seen as helping us protect our resources, while resilience is useful to prepare for and embrace change. Change associated with disruptions to operability and functionality of our infrastructure systems, for example. However, in some fields and areas, there is a certain level of confusion associated with sustainability and resilience. They're both important concepts, but they're not the same. Sustainability focuses primarily on maintaining and improving the quality of life indefinitely, while resilience focuses on adapting to changing conditions, withstanding the effects of hazards, and recovering rapidly from disruptions. So one could think of resilience as that attribute that helps maintain the dynamics of an infrastructure system or a network. At the same time, sustainable systems may or may not be resilient, while resilient systems may or may not be sustainable. Now, even though they're different, they're also synergistic. For instance, sustainability is associated with concepts such as renewable, a complete service life of a facility, efficiency, reduced energy consumption, the use of recycle and reclaimed materials. When it comes to resilience, one thinks of robustness to withstand the effect of hazards, redundancy to serve the same purpose, dynamics in terms of preserving the dynamics of a system, recovery, operability, and functionality. But what they have in common, both of them actually relate to community, the sustainability of a community, the resilience of a community. They both relate to systems and the interdependencies between systems. They both relate to resources, response, adaptation, environmental impact, and last but not least, diversity, inclusion, and equity. As an example of the synergy between resilience and sustainability, we have the image on the screen that presents a conceptual framework associated with earthquake engineering and earthquake design. For instance, at the bottom of the screen, you see an older building that hasn't been retrofitted that is exposed to a major earthquake event. That building is represented by the cartoon at the bottom of the screen. Now, towards the middle of the screen, you see expected building downtime, a year or more. But at the far right, we want to focus on the carbon impacts of repairs. So the building has low robustness, which translates into a low level of resilience, right, that is directly related to a relatively high carbon impact of repairs, which also corresponds to a low level of sustainability from that point of view. Now, once a basic retrofit of a building is conducted, now the robustness of the building will increase, its resilience will increase, and the embodied carbon, and more specifically, carbon impacts associated with repairs are expected to decrease. Now, finally, if more robustness is added into the design and construction of the building, which is associated with following basic code or even enhanced code provisions or implementing protective systems into the design and construction of a facility, the expectation is that as the resilience increases, the carbon impacts of repairs will decrease, repair costs will decrease, and the expected building downtime will also decrease.
Let's now talk about how actual examples can show us that sustainability and resiliency can be incorporated. We'll go through three case studies: one, a finished building, one that is under construction, and one example will highlight infrastructure. The first case study is the Spalding Rehabilitation Hospital. Disclaimer, this is not a Turner job. But you can learn more information on, I'm going to give you two resources. I'm sure there are many. One is the ULI Returns on Resilience Study, and the other one is the US Climate Resilience Toolkit. In 2005, Partners Healthcare, which is the client that built this building, purchased a contaminated brownfield and constructed a replacement for their current rehabilitation hospital. The hospital is located in the Boston Harbor, right at current sea level. And it opened in 2013 as an example of resilience to sea level rise and other hazards. The first floor of this building is elevated 30 inches above the FEMA 500-year flood elevation. Side note, that is the elevation that floodwaters would reach during a flood so extreme that it has only a 0.2% chance of occurring each year. Now, that is based on historical data, and future climate projections have shown that a 500-year flood elevation actually has a higher percentage of happening. Another explanation is that a 0.2% chance happens only in the first year of the building, and it compiles over time. Back to the building. This elevation, the elevation of the first floor, was much higher than required by code. And Partners Healthcare also ensured that despite that elevation, there will be universal access for rehabilitation patients, which also shows another aspect of resiliency, making sure that everyone has access to facilities like this. Other resiliency and sustainability features include high voltage service goes all the way up to the roof. Normally, the utility transformer sits outside the building on the ground level. Again, not in this case. It goes all the way up to the roof and it's encased in concrete. Generators can run up to 4 days. The building envelope is super insulated with foam in the walls and triple pane glass in patient rooms, avoiding the need for baseboard heating, which is very common in Boston because of the cold winters. Around the building, there's landforms like swales and berms that act as a barrier reef and deflect waves from hitting the building directly. An example where sustainability and resiliency here have a synergy is those triple pane glass. That's a passive strategy that keeps the building at a constant temperature. So imagine a summer day. It takes longer for the interior of this building to become hotter and have a need for AC. Similarly, in the winter, if it's really cold outside, it takes longer for the building to become very cold and need heating. This triple pane glass, it's also a resilient feature because it can deal with extreme temperatures. So there's synergies between sustainability and resiliency. Now let's talk about that high voltage that goes all the way up to the roof and it's encased in concrete. That's a resilient feature, but not really a sustainability feature. That encasement in concrete, it's a lot of resources. Concrete is very heavy in embodied carbon. So there, the designers have to sit down and say, okay, what gives up? What do we give up? Sustainability or resiliency. And that's really important to do when it comes to the design of a building, is evaluate what are the priorities of the building? What's the building used for? What are the hazards? What are the risks? What's the downtime that a building can withstand and be okay with? The study called Safe Haven Study, published by Healthcare Without Harm and PricewaterhouseCoopers, also highlighted the Spalding Rehabilitation Building. And he told us that the investment in resiliency and sustainability paid off within 18 months. This building is 30% more efficient than the typical hospital or hospital that just meets code. And every year, Spalding has 500,000 savings in annual energy, again, compared to a building that just meets code. Let's move on to our second case study. This is the Connie Island Hospital, a Turner job that is right now under construction. As you can see in the slide, it is located 200 feet away from the water, right when the Atlantic Ocean comes into New York. The existing building was hit by Sandy. It was a complex of buildings that lost power, lost water service because all the critical infrastructure was in the basement. And so the role of this new tower was not only expand the space for patients and staff, but also to house a central utility plant on the fifth floor. Similar to Spalding, high voltage electrical service goes all the way up to the fifth floor. And the utility transformer is also on the fifth floor, and it feeds the entire complex. Seeing the picture in the rendering how the ER is located in the second floor. And I don't want to underestimate community resilience, because if the first floor is flooded, cars probably won't get to the second floor. So all sorts of resiliency are needed. Buildings that are resilient and communities that are also resilient. But for the purpose of this example, we'll focus on the building. What I really want to highlight about this project is that during the construction, resiliency and sustainability measures were incorporated. Take a look at the picture on the right. Those are HESCO barriers that were deployed around the perimeter of the entire hospital during hurricane season to protect not only the existing building, but also the construction site during construction. The picture on the left shows the temporary electrical service being elevated on concrete pillars. As you can see, these solutions are not rocket science. They're simple, they're available, and they pay off in the life cycle of even the construction site. Our construction sites are vulnerable. Our workforces are vulnerable to the weather, and incorporating resiliency measures such as this can help us not affect the schedule, our workforce, and potentially our profits too. Sustainability measures that were incorporated in this job site includes water fillers distributed throughout the site to reduce water bottle usage and waste, light sensors in our trailers to reduce energy usage, temporary lights that were all LED, and a no idling mandate that we instill in all of our sites to reduce greenhouse gases emitted during the construction from vehicles. Let's move on to our third case study.
Yeah, now let's talk about infrastructure right now, with the third case study being the Culvert System. Now, this is a conceptual case study where the focus is on preventing the damage that you see on the screen right now. This was damage to a culvert system under extreme flood conditions, which clearly disrupted traffic on that particular roadway. Now, think about the disruption of or potential disruption of traffic to the roadway network and to the surrounding community. When we talked about a culvert system, this is defined as that system composed of a soil embankment, as you could see on the screen, the pipe or the culvert itself, and the pavement on top of it. Now, under extreme flood conditions, right, most damage occurs due to a condition called water overtopping roadway, as you could see at the top there on the left corner, water eroding, overtopping the roadway and eroding the other side of the roadway. One could also have water infiltrating into the soil and debilitating it. And finally, in a coastal area, for example, one could have wave erosion debilitating the embankment. So one of the things that can be done to prevent the failures of the previous slide is to strengthen and protect, is to increase the robustness, the resilience of the soil embankment. Now, as designers, people have options. The embankment can be protected using materials that have higher embodied carbon. That could potentially provide a higher level of resilience at the expense of a lower sustainability by that particular metric. Let's think right now about the case of a wildfire in the vicinity of the culvert system. Disruptions could take place by virtue of the fact that the culvert structure may be damaged due to high heat. One alternative is to clear or keep a certain distance from the culvert system to the wildfire front clear of vegetation. That is represented on the right-hand corner by that distance called the wildland to culvert offset. This implies more frequent maintenance to increase resilience at the expense of perhaps a higher carbon footprint. An alternative to keeping that distance with low vegetation is to actually build the culvert structure itself with high heat resistant materials, which could come at the expense of a higher embodied carbon on the culvert structure itself. So as you can see, this is a conceptual example, a case study where sustainability and resilience could be at odds with one another, but one should take into consideration the whole life cycle of the project, and then it becomes a balancing act to account for both sustainability and resilience into the project. Now, what are the takeaways of our discussion so far? First and foremost, sustainability and resilience are essential for our future in this planet. Secondly, they can often be synergistic, which implies that they can be incorporated without one compromising the other. We had the example of an earthquake and decreasing the carbon impacts of repairs by increasing the resilience during the design and construction of a facility. In some other cases, sustainability and resilience can be in conflict with one another, which was also demonstrated by the Culvert case study that we recently discussed. This implies that incorporating both may require a balancing act. Sustainable and resilient solutions exist for our built environment, and that's the good news. The solutions are available, or it's up to us to work to implement them.
Now, climate crisis is not an environmental crisis. It's a people crisis. It's affecting us already and will continue to affect us. The good news is that we can all do something about it, especially us in the construction industry. We discussed how impactful buildings can be. At a minimum, we contractors can bring up the topics of resilience and sustainability to the conversation. We can figure out our clients' needs and figure out how to incorporate sustainability in resiliency and how that can bring value to our clients' priorities. Three main things should be thought about: the geographical location of the building, the type of building, and the amount of risk that the client and the building occupants can withstand. We can incorporate sustainability and resiliency into our construction sites. Solutions already exist, and we must evaluate future climate and plan for it both on our construction sites and in our finished buildings. Historical climate is a thing of the past. Our sites are vulnerable to the weather. Our workforce is vulnerable to the weather. We must plan for extreme weather events affecting our sites and our workers. Our industry will only benefit from this. Thank you for listening to our presentation. Our emails are on the screen. We will be glad to continue the conversation.